Okay. Hindi naman putol-putol ang boses ko dyan. Kasi para may delay.
Hindi pa naman po, sir.
Okay. So, good morning, everyone. So, it's nice to see you again virtually. So, for today, we're going to proceed with our new topic in solutions thermodynamics. So, we're going to have our lecture. So, this presentation is entitled The Solutions Thermodynamics, specifically the applications of solutions thermodynamics. So in this part of our lecture, we will be talking about the different applications of solutions thermodynamics. So let's start with the table of contents or the contents of this presentation. So for today, we will be focusing on the applications of solutions thermodynamics. So by definition, when we say excess properties, they are defined as the difference between the properties of solutions. So we're going to focus on the applications of solutions thermodynamics. Okay? So for this discussion, we will be talking about three subtopics. Particularly, we will be discussing the nature of excess properties, also the mixing processes, and lastly, the heat effects of mixing processes. So during our discussion in solutions thermodynamics, I was able to introduce different properties to you. So we started with the fundamental properties of the thermodynamics. We also discussed your residual property, your reduced property. And now we're going to focus on another important property in thermodynamics, which is all about the excess properties. Okay? So, nasa meet pa ba ako?
Opo, sir.
Okay. So, we're going to talk about your excess properties. So, by definition, when we say excess properties, they are defined as the difference. Okay, wait lang. So, they are defined as the difference. Sabi natin, this is the difference between the property of your real solution and the ideal solution. So this excess property is called the residual property. So para lang din siyang ang ating tinatawag na residual property. But the difference here kapag residual property, this is the difference between your real gas and your ideal gas. Okay? So kapag ang pinag-uusapan natin ay gases, ang tawag sa difference ng ideal at ng actual is the residual property. But when we are talking about solution, so solutions na ang ating pinag-uusapan, the difference between the real solution, that property is called the residual property. So para lang din siyang continue with the excess properties. So just like what I have said a while ago, so when we say excess properties, we are dealing with the difference between your actual property and your the difference between your between the Again, this is the difference between the property of your real solutions, particularly the deviations of the properties of the solution. We are talking about its excess properties. So, anong pinagkaiba niya with our residual property? So, sabi natin, by definition, itong si residual property, these are the property or the difference between the properties of the ideal gas and the real gas. So kapag ang pinag-uusapan natin ay deviation of residual property, but when we are talking about the properties of the solutions, we have here a property M raised to E is equal to M minus the property of the ideal M. We are concerned with excess properties. Okay? So, in studying excess properties, we have this general formula. We have here ME. So that is how we represent an excess property. So we have here a property M raised to E is equal to M minus the property of the ideal M. Okay? So we have here ME for our excess property. So this one. And then M for our molar property of real solution. So for this one is for the real solution. And sabi natin by definition, this is the difference between your real solution and ideal solution. So this one, M raised to ID, is for your ideal solution. Again, here, M can be any property. So pwede siya maging entropy, enthalpy, volume, and such. Okay? Is that clear? Narinig niyo pa doon?
Yes po, sir. Clear naman po.
Hello?
Medyo nagputol lang po sa ibang part pero okay naman po.
Okay. So, okay lang. Paano ako ha, pag nagtatanong ako, pasagot agad ako kasi hindi ko alam kung na-disconnect na ba ako sa Meet or what. Ano, para lang alam ko na nasa Meet pa ako. Thank you. Okay, so let's continue. Again, this is the general formula for excess property. We have here your excess property is equal to the difference of your molar property of real solution and your excess property of ideal solution. So this one and your ideal. So we're going to focus on the first one. Your excess gives free energy. This comes from experiment through the reduction. We can get the excess gives free energy through an experiment involving your VLE data. Okay. For the other one, the excess enthalpy, this is being determined by mixing experiment. So, na-determine naman siya, this property, property through the ginamit dito ay experiment using the VLE for excess. And for our last one, so we have here excess entropy. So for excess entropy, unlike the two, we don't have a direct way of measuring the excess entropy, but we can relate actually the excess entropy through this equation. So saan ba ito nanggaling? This comes this comes from your delta G, your gatas. So, di ba meron tayong delta G is equal to delta H minus T delta S. Okay? So, para makuha natin si delta S, then makukuha natin itong equation na ito. Okay? And we can use this equation to relate or solve for the S equal to the excess enthalpy minus. So, did you get that?
Yes po,
Yes
sir.
po, sir.
Okay. So, let's continue with, man din siya. So, same lang. These three properties are all functions of your temperature, pressure, and this one. So, actually, this is an experimental data or graph involving the six binary liquid mixture at 50 degrees Celsius. So, ito yung trend ng properties na pinagbasihan. That's why we come up with your excess enthalpy, gives free energy, and your T delta S. Again, so this graph is based at 50 degrees Celsius at approximately atmospheric pressure. So ano ano ba yung graph na ito? So for letter A, so based from the legend, ang letter A daw is for letter B. So ito yung graph ni acetone and methanol. Okay? For letters for letter C, so based from the legend, ang letter and so on and so forth. Okay, so these are the six binary liquid mixture delta G, delta H, and T delta S. Now, observe this graph. What are the observations or the common features that you can observe between this one? So, bibigyan ko kayo ng example. Let's say, for example, inobserve natin si T delta S. And nakita nyo, lahat ng value ni T delta S ay nasa taas. So, ano observation natin doon? Ibig sabihin, pwede nating masabi that your ano, so kasi lahat nung kung makikita nyo ang mga value ni so this is one observation. So can you give me more observations about this one? Anong masasabi nyo kay delta G? O, si delta G nandito sa una, tapos sa pangalawa nasa baba din. Ano masasabi niyo sa value ni delta G? Kung si T delta S ay positive, ano kaya yung mga value ni delta G? Okay, so pwede niyong ilagay sa comment kung nahiya ko yung magsalita. Titingnan ko na lang. Ayan. So, paki-comment ng inyong observation. Ano kaya yung na-observe nyo sa value ni delta G? Kung nahihiya magsalita, tingnan uli natin. Ito si delta G. Ano makikita nyo kay delta G? Nasaan siya? Siya ba ay positive din? Okay, so negative daw. Okay, so that is actually correct. Ano? So actually, as you can see in our graph or the trend in our graph, your delta G has negative value. So very good. So delta G is negative. Ano? So makikita natin ang ating delta G ay nasa negative value. So that is our next observation. So our delta G is negative. Okay, is negative. Okay, now, ano naman ang masasabi nyo kay delta H? Sa unang graph, nandito siya nasa taas. Ito, nasa baba. Nasa taas din, nasa taas and baba, and nasa taas and baba. So, ano masasabi niyo naman kay delta H? Sige nga, anong ma-observe natin kay delta H? So, rinig niyo ako. Ang hirap pala pag-online dito.
Yes po, sir. Rinig na po ulit.
Saan ako naputol? Narinig niyo yung discussion ko about trend about enthalpy na either positive or negative siya.
Opo.
Okay, so dun ako naputol sa composition kapag pure species. Tama?
Dun po, sir, sa nagtatanong po kayo ng yun sa DH daw po.
Okay, so pa-message na lang uli pag na-disconnect. Okay, so let's now focus on the trend kapag naman ang ating given solution or kapag ang ating property ay nag-approach sa pure species. So, di ba kapag sinabi natin pure species, so it's either 0 or 1 ang kanyang mole fraction. Ito 'yon. Kasi 'di ba X1 'to, so naka-mole fraction 'yan. Ayan.
Sir,
So,
excuse me
anong
po.
masasabi nyo kapag nagiging pure species yung ating property or yung ating given solution?
Sir,
So, ano makikita nyo sa value ni TDA, delta E, delta G? Yes?
excuse me po, sir.
Oh,
Wala po naka-present po.
ano yun?
Wala pong PowerPoint po na naka-present.
Ah, can share your screen. Sorry, an error when screen sharing. Okay, ang dami naman problema ng Google Meet. Wait lang. Nako, hindi natin to matatapos ngayon. Dami, ang hassle. Kita niyo na ang screen ko?
Hindi pa din po.
Hindi pa rin? Okay, wait lang. Nagsha-sharing na. Ayan, kita niyo na.
Kita na po, sir.
Okay. Ah, okay, so just as I was saying, anong na-observe nyo sa property kapag nagiging pure species ang ating solution. So katulad dito sa zero and nag-approach sa 1. Ano kaya ang nangyayari kay T, delta S, delta H, and delta G? So sa tingin nyo, ano nangyayari sa value nila kapag 0 and 1 yung paki-comment ulit ang inyong sagot. Okay, hindi ko makita mga comment. Pero ano napapansin niyo doon sa property?
Nag-equalize po yung values nila as they
Dito,
approach
kapag halimbawa
ideality.
0 or 1 yung concentration, ano ang nagiging value ni T delta S, delta H, at delta G? Dito 0, tas dito sa 1. Anong nag-a-approach saan yung kanilang values? Nag-i-equalize sa approaches 0. Very good. So, tama yung observation ni Kyla. So, as your X1 or the composition approaches pure species, 0, delta H, and delta G also approaches to 0. So, nagiging 0 din yung kanilang value. Okay? So, to sum it up, our observations, so actually, merong 5 observations na pwede kayong makita dyan. Number 1, so delta G is always negative. So ito na yung una nating na-observe. So ang atin daw delta G, tatandaan niyo ito, that our delta G is always negative. So our next observation is about delta H. So nakita natin kayo na sa graph na si na-disconnect.
Sir, doon po sa may ano,
Doon sa third
yung
observation, yung approach check to zero.
opo.
Okay. Hi. Ay, stress naman mag-online class dito. Okay, so let's continue with the observation. So dito daw tayo natapos with the observations to the value of the properties of the pure species. So kapag nag-a-approach yung ating mole fraction into 1 and 0, based on the graph, the values of delta G, delta H, and T delta S also approaches to 0. Now, another observation is the value or the trend in the T delta S. So, nakita natin also sa graph na the value is always positive. Okay? And for the last observation, ang ating daw maximum or minimum value ay nakikita or often appear at the center or at 50% mole. So, tingnan natin kung tunay iyon. So, kung makikita natin dito sa graph, sorry, dito sa ating graph, dito sa unang graph, di ba nandito yung kanyang pinaka-peak or maximum value nasa gitna. Ang kanya namang lowest value nasa gitna din. Ganon din dito sa pangalawang graph. Ano? So, kaya na-generalize that the maximum and minimum value often appear at the center of the graph or at the mole fraction of 50%. Okay, so this summarizes the observations using the six binary liquids at 50 degrees Celsius. Okay, is that clear? Hello? Nasamit pa ba ako?
Clear po, sir.
Okay. So, now, we're going to focus on the common features. So, actually, ito lang din yung mga na-observe natin. So, meron tayong three common features. Excuse me. So, ito yung sinasabi natin kanina that all excess properties become zero. So, nagiging zero daw sila as either of the species in our solution approaches purity. Di ba kapag sinabi natin purity, nagiging pure species. So kapag nagiging pure species sila, ang kanilang excess properties ay nagiging zero. Ano? Next, all excess gives free energy versus the composition or the mole fraction is approximately parabolic in shape. So tingnan natin kung parabolic nga ba siya. So kung makikita natin, ito ang ating delta G, di ba? Parabola siya in shape. Ito. Yung nasa baba. Ito mga delta G. Ano? So tama siya. So both HE or excess enthalpy and excess entropy exhibit individualistic composition. So kung makikita nyo, meron silang separate graphs for every property because they have their individual property. Ano? And next one, when an excess property M raised to E has a single sign, the extreme values or the minimum and maximum values often occurs at the equimolar composition. So ito yung ating nasa center. So ang ating composition ay 50% or 0.5. Okay? So these are the common features of your six binary liquid mixtures. So let's have here an example. So paano ba tayo nagsosolve when we are having that kind of problem? So this is an example for an ethanol and chloroform mixture. If delta G, so we have here the given delta G is equal to negative 750 joule per mole, and delta H is equal to 750 joule per mole, estimate the entropy change of mixing. So anong first step natin? So 'di ba meron tayong anim na given for the binary liquid solution. Ang una niyong gagawin ay hahanapin niyo yung graph for the ethanol and chloroform. And ito yung graph na yon. Ano? So out of 6, hahanapin nyo alin ba dito yung para kay ethanol and kay chloroform mixture. Okay? So let's try to solve. So ito yung ating given na graph. Now, meron tayong given na ating delta G daw ay negative 750 joule per mole. And our delta H is 750 joule per mole. So, ang first step natin ay ipa-plot natin yung ating given. Ano? So, nasaan ba dyan si negative 750 na delta G? Di ba ito yon? So, approximately, nandito sa dilaw. Kita nyo to? Wait lang, papalitan ko yung kulay. Ayan. So, kita nyo tong kulay dilaw na line? This one? Nakikita nyo pa ba?
Opo, sir.
Yes po,
Okay,
sir.
so
Yes
pinlot
po.
natin yung given na delta G. So approximately, ito ay, kung yari, ito ay negative 750. So nandyan daw yung ating delta G. Now, from your delta G, ipa-plot nyo rin yung given na delta H. So ang given natin na delta H ay ito. So meron daw tayo ditong given na delta H na 750. So kunyari, nandito siya, 750. So ito yung ating delta H, and then ito yung ating delta G, then ipo-project nyo lang siya, itong line na orange, para makuha nyo yung ating TDS. Kasi ito yung ating hinahanap, change in the entropy. Now, based on the graph, sa tingin nyo, ano kayang value ng ating TDS? O, sige nga, sukatin nyo nga yan. Mga ano kayang estimate nyo dyan? Ito daw ang TDS natin, itong nasa green line na ito. Ano kayang sukat niyan? O, ito 1,000. Tapos, lumaki lang siya ng konti. O, ano yun? Sa tingin nyo, anong value ng ating T delta S?
1,500 po.
Okay, very good. So, meron tayong T delta S na 1,500 joules per mole. So, as easy as that, meron na tayong value ng ating T delta S. But, in our problem, we are looking for the entropy change of mixing. Ibig sabihin, ang hinahanap natin ay delta S lamang. Okay, now, question. Ang nahanap natin sa graph ay T delta S. And alam natin na ang formula natin for delta S ay delta H minus delta G over T. So, pwedeng natin itong gamitin. Or pwede rin namang ito. Same lang naman sila ng lalabas. Ano? Question, meron ba tayong given na temperature? May binigay ba na temperature?
Wala po.
Yes. Walang directly binigay, but based on our discussion earlier, sinabi natin na ang graph na ito ay ang kanilang mga graph at what temperature yon. Kung natatandaan nyo.
Yung 50 degrees Celsius po.
Okay, very good. So, ito yung sinasabi natin kanina. Ito yung 6 binary liquid at 50 degrees Celsius. So, automatically, magagamit nyo yung 50 degrees Celsius. Kasi yun yung graph or trend ng graph at 50 degrees Celsius. Ano? So, we can easily solve for our delta S. That is, we have 750. Sorry, wait lang. Okay, so meron tayo ditong 750 for our delta H minus negative 750 for our delta G. So direct substitution lamang ito all over your temperature na 50 degrees Celsius plus 273.15 para maging Kelvin siya. Okay, so meron tayong value na delta S is equal to 4.6418 joule per Kelvin. So nakuha niyo ba ito? Or simply, i-divide nyo lang itong 1.5 sa ating temperature para delta S na lang yung matira. So, same answer lang din naman siya. So, nakuha nyo ba si 4.6418 joule per Kelvin?
Yes po.
Okay, thank you. So, let us now proceed to our next one, the mixing properties. Okay, so for mixing properties, we will be talking about the property changes of mixing. So na-introduce ko na siya during our concepts for ideal gas. We already solved for the property changes of mixing of ideal gases. But for now, we're going to talk about the solutions. So the thermodynamic properties of mixtures are required for the analysis of mixing and unmixing processes. So in our industry setup, meron tayong mga mixing process. So it is important that you know the changes or the effect of mixing to the properties of our solutions. So in general, we have here delta M, or the property change due to mixing is equal to M minus the summation of your mole fraction times M sub I. Okay? Where M here, katulad ng sabi ko kanina sa excess properties, this M can be any intensive thermodynamic property. So pwede siya maging internal energy, pwede siya maging TP, entropy, and gives free energy and such. So, kapag sinubstitute lang natin, let's say property changes or excess volume is equal to the volume minus the summation of xi volume I. So, itutulad lang natin ito dito sa ating general formula for mixing processes. Ano, kaya nakuha yung mga equation na ito. Okay? So, for our enthalpy, so ito to, so excess enthalpy is equal to H minus the summation of Xi, Hi. So, ganun din dito kay excess entropy and excess gives free energy. So, meron silang relationship sa excess, ano, so pwede natin siyang i-simplify. So, again, ito yung ating general formula for the property or changes due to mixing. Tapos, ito yung ating, kung makikita nyo, ito yung ating formula for excess property. So excess volume, excess entropy, excess enthalpy, and gives free energy. So kung makikita nyo, itong si excess volume, entropy, and gives free energy, yung pattern ng formula niya ay parang ito lamang din. Ano? So, kaya, pwede natin sabihin na ang excess volume is just equal to the property changes due to mixing ng volume. Yung change ng mixing sa volume. Ganun din sa ating sa ating enthalpy. So, equal lang din siya kay delta H. And sa ating namang excess entropy, equal siya kay delta S plus Rxi ln xi. Ganun din sa ating, excuse me, gives energy. Ano? So, pinalitan lang natin ito, yung V minus, katulad nito, yung V minus the summation of xi vi nitong delta V. Kasi same pattern lang siya doon sa formula. Okay, so these are the simplified version of the formula for our property changes of mixing. Ano? So let's try to focus now. And nga pala dito sa excess property, so babalikan niyo rin yung mga partial property. Because meron tayong tinatawag na binary system with partial excess property. So same lang naman siya doon sa ating formulang nauna for partial property. So papalitan niyo lang siya ng mga excess property. Ayan. So, same formula lang naman ito. Ang gagamitin nyo nga lang notation, ay dilalagay nyo ng capital letter E to signify that it is an excess property. Okay? So, ito rin yung formula natin for partial property ng solution ng component 1 and partial property ng component 2. So, di ba dinerive naman natin to last time na sila ay naka-base kay DME with respect to DX1. Okay? So, is that clear? Nakahabol pa dito?
Yes po.
Okay. So, again, this is the formula for your partial excess properties. So, let's try to solve. So, example, a binary mixture at 70 degrees Celsius has the following departures. So, we have delta G x1 joule per mole is equal to 400 x1 squared minus 400 x1. Next, uh, excess enthalpy is equal to 5,000 x1 minus 5,000 x1 squared. Question, what are the maximum values of the Gibbs free energy and the enthalpy of mixing? So, tinatanong natin maximum value. Na daw kaya yung kanilang maximum value? Next, at what compositions these values exist? And determine the departure function for the enthalpy. Sorry, this is enthalpy nga. No, this is not enthalpy. Entropy to. Entropy of mixing. Kasi may given na tayo for enthalpy ito. Okay? So, paano natin siya isa-solve? So, dun muna tayo sa question A. So, what are the maximum values of the Gibbs free energy and enthalpy of mixing? Now, alin dyan si Gibbs free energy? Anong equation iyon? Alin kayang equation yung para kay Gibbs free energy? Sige nga. So, unahin natin si Gibbs free energy. So, aling equation ang gagamitin natin dyan?
Yung may
Hello?
delta G po.
Yung may delta G. So, anong value yon?
400x1 squared minus 400x1 po.
Okay, very good. So, kapag ang hinahanap natin ay Gibbs free energy, syempre, ang gagamitin nyo yung may delta G. So, gagamitin natin ang equation na ito, delta G x1 equals 400x1 squared minus 400x1. Now, ano ang gagamitin nating value ng x1? Sabi natin, maximum value. So, sa observation natin kanina, saan daw nag-occur kapag maximum value? Anong mole fraction? Para daw maximum yung value ng ating mga properties. Doon sa observation natin, saan gas siya nag-occur? Anong composition? Anong mole fraction? Ano kayang gagamitin nating value ng x1 para masabi nating maximum value iyon?
0.5 po.
Okay, very good. So, ito na, lumabas na dito. So, ang gagamitin natin is 0.5. Kasi nga, sabi natin sa observation natin kanina sa graph, na yung kanyang maximum and minimum value ay nag-occur at the center of the graph, of the diagram. So, that is at 50% mole fraction or 0.5. So, basic lang naman ito. You're just going to substitute 0.5 in every value of your x sub 1. So, meron tayo ditong 400 times the quantity. 0.5 squared minus 400 times 0.5. So, what is our final answer for delta G? Ano kaya yung maximum value niya? Sige nga, paki-compute and paki-comment ng inyong answers. Titingnan ko kung nagsasolve. Ayan, lumabas na. O sige, susunod na lang. Ay, mali. Okay, so nakuha niyo ba itong C100? Si negative 100 joule per mole?
Yes po.
Yes po.
Okay, very good. So this is our answer for the maximum value of your delta G. Okay? So kayo naman na mag-solve nito. Ano naman yung maximum value ng ating enthalpy of mixing? Wait lang. Ayan. So ano ang ating value ng ating enthalpy of mixing? Sige, yan. Lumabas mo. Wait. Tapos paki-comment ang inyong sagot. So, enthalpy of mixing, ang gagamitin nyo, yung formula for enthalpy. Ano? Yung departure function. So, again, maximum value ang hanap natin. So, 0.5 ang gagamitin yung value for our x1. So, ano nakuha yung value? Titignan ko ang mga nag-comment. Nakita nyo na. Okay, very good. That is 1,250 joule per mole. Ano? So, very good. So, this is how you solve for the maximum value using our departure function. So, meron tayo dito 1,250 joules per mole. Ano? So, let's focus on letter B. At what compositions does this value exist? Ano kayang value niya? Ano kaya sagot natin dito? Saan daw siya nag-exist? Yung mga values na nakuha nyo? Anong composition? Anong value ng X? 1.
0.5 po.
Okay, very good. So, meron tayong x1 is equal to 0.5. Ano? Kasi doon nag-exist yung kanyang maximum value. Now, dito tayo, determine the departure function for array entropy ha. Ulitin ko, ito ay entropy. So, paano natin siya makukuha? Di ba mayroon akong inintroduce na formula na delta S is equal to your delta H minus delta G all over the temperature. So, direct substitution lamang tayo dito. So, meron tayong formula for our delta H. Ito to, yung ating given. Meron tayong 5,000 x1 minus 5,000 x1 squared. And then minus yung ating formula for our delta G. Ito yung given natin, 4,000 x1 squared minus 4,000 x1. And then meron naman tayong temperature na given which is, I think 70 degrees Celsius ang given. So, ia-add mo yung 273.15 para maging Kelvin ito. Kaya meron tayong 343.15. Ano? So, kindly simplify this one. Anong ating sagot diyan? Paki-comment uli ng inyong answer. Ano, hindi. Ang tanong sa atin ay departure function. Ibig sabihin, ang ibibigay nyo ay equation. Ano? So, yung simplified equation, hindi nyo kukunin yung maximum value. Kasi ang tinatanong ay departure function. Yung parang pinaka-equation daw na magagamit for our entropy. So, isi-simplify nyo lamang ito. Ayan, so lumabas na yung sagot. Etong taas na to. So, sige nga, paki-simplify. Nakopyan nyo ba? Or ayun. So, ito mga value siguro na 3.93, I think ito yung maximum value niya. Pero the question is looking for the departure function. Kapag sinabi nating departure function, ang ibibigay niyong sagot sa akin ay function. Ibig sabihin, naka-equation. Ano? So, kaya, pag sinimplify natin siya, makukuha nyo itong negative 5,400 x1 squared plus 5,400 x1 all over t. So, ito yung ating final answer. Nakuha nyo ba ito? So, negative 5,400. So, combining like terms lang siya dito. And this is our final answer. Okay? So let's continue with our third example. So the heat of mixing for liquid species 1 and 2 at fixed temperature and pressure measured calorimetrically is represented in some appropriate units by the equation x1 times x2 times the quantity 40x1 plus 20x2. Determine the expressions for partial excess enthalpy 1 and partial excess enthalpy 2 as functions of x1. So, nandito na tayo kay partial properties. Ano? So, ang hinahanap daw natin ngayon ay ang ating partial property ni H1 and partial property ni excess H2. So, tanda pa baga ang ating ginagawa kapag partial property? Try nyo itong isolve. So again, as functions of a x1. So anong una natin gagawin? So lahat ng x2 ay papalitan ng, anong ipapalit natin kay x2? So x2 equals, saan siya equal? So dapat daw naka x1 lang lahat. So anong ipapalit natin dito kay x2?
1
1 minus
minus
x.
x1 po.
Okay, very good. So that is 1 minus x1. So try natin. Lahat ng x2, pinaltan ko ng 1 minus x1. Tapos ito din, pinaltan ko rin siya ng 1 minus x1. So ito yung counterpart ni x2. Ayan, wait, papalitan ko ng kulay. Okay. Now, meron na tayong equation for our delta H na lahat ay naka-x1 na. So, pakisimplify nga ng taas na ito kung ano ang inyong makukuha. Sige, solve nyo. Okay, so na-simplify nyo ba? May nag-comment ba? Wait nga, titingnan ko. Ano to? Bakit? Ito, 20x1 minus 20x1 cube. Negative 20x1 cube plus 20x1. Okay, very good. So, meron naman pala nakapag-simplify. So, ito yon. So, ito yung ating naka-delta x1. So, titingnan natin ngayon, kapag sinimplify natin, so, eto. So, nakuha niyo ba ito? So, itatimes lang natin siya. X1 times 1, that is x1. X1 times negative x1, that is negative x1 squared. And ito rin, 20 times 1, that is 20. 20 times negative x1, that is 20x1. Ano? And then, i-simplify natin by distributive property hanggang sa makuha natin ito, 40x1 squared. Ito yon times x1 times 20, 20x1, negative 20x1 times x1, that is negative 20x1 squared. Dito naman, negative x1 squared times 40, kaya meron tayong negative 40x1 cube, negative x1 squared times 20, negative 20x1 squared, negative x1 squared times negative 20x1 squared is 20x1 cube. And then kung makikita niyo yung may mga kulay, yan yung magkakatulad ng terms. Yan yung inyong pagsasamahin. Ano? So, meron tayong 40x1 squared minus 20x1 squared minus 20x1 squared. So, 0 na iyon. So, ang natira na lang ay 20x1 minus 40x1 cube plus 20x1 cube. So, negative 40 plus 20. So, itong dalawa na lang yung natira. So, that is negative 20x1 cube. So, tama yung mga nagsagot. Meron tayong simplified version na 20x1 minus 20x1 cube. Now, as you can see or as you remember in our solution, kailangan nating makuha yung ating DHE with respect to our dx1. So anong gagawin natin dito kay delta H? Anong process? Para makuha natin itong DHE, ano kayang gagawin natin? Anong tawag doon? Anong process ang gagamitin natin para magkaroon tayo ng DHE? Okay, very good. That is derivative. So, i-derivative natin itong ating delta H. So, what is the derivative of this one, ng ating delta H? So, paki-comment ang inyong sagot. So, negative 60x1 squared. Okay. Tingnan ko mga comment. Plus 20. Okay, very good. So our derivative here is 20 minus 60x1 squared. Ano? So ito na yung ating derivative. So, derivative lang natin yung derivative ng 20x1. So, syempre, that is 20. Tapos dito, yung 3 pupunta sa unahan. So, that is 3 times 20. That is negative 60. And then 3 minus 1. Kaya naging squared na lang yun. Okay, so thank you for your answers. Now let's continue. Meron na tayong delta H, may value na tayo. Meron na rin tayong DHE over DX1. Now, let us recall the formula. Ito yung formula natin for partial exist property. So sabi natin, meron tayong partial proper excess property ni M1 ay equal kay M E or excess property ni M plus 1 minus x1 times the derivative of your excess property with respect to x1. Ano? So meron na tayo ditong HE. So sabi natin, ang delta H ay equal lamang din kay HE. So, meron na tayong HE. Tapos, meron na rin tayong DHE over DX1. So, this is just a direct substitution. So, substitute natin siya. Ito na yung nangyari. So, meron tayong 20x1 minus 20x1 cube. So, this one is for your HE. And then, plus 1 minus x1 times 20 minus 60x1 squared. So, this one is for your DHE with respect to dx1. Okay? So, simplify this one. Ano magiging sagot kaya natin for our partial property of excess enthalpy 1? Sige, paki-simplify. Okay, so meron akong nakitang 40x1 cube minus 60x1 squared plus 20. Very good. So that is our final answer. So meron tayo ditong 40x1 cube minus 60x1 squared plus 20. So kung makikita nyo, kapag sinimplify natin ito ang kinalabasan. Tapos yung magkakakulay dyan, ibig sabihin, yun yung ating like terms. So, meron tayong 20x1 minus 20x1. So, 0 na ito. So, ang natira naman ay 60x1 cube minus 20x1 cube. Kaya naging 40x1 cube. And then, copy lang natin yung negative 60x1 squared and then plus 20. And by this, nakuha na natin ang ating partial property of enthalpy 1. Okay, very good. Tama ang inyong mga sagot. Ano? Now, hanapin naman natin ang ating sunod na property. So, our next target is the partial property H2. So, paano ang formula natin? Ito naman ang ating formula for H2. So, meron tayong ME or excess property minus x1 dme over dx1. So, same process. I-substitute lang natin ito and then paki-simplify ulit. Ano? So, this one is your delta H or yung ating HE. Tapos, ito naman yung inyong DHE over dx1. So, what is our final answer? Okay, so nakikita kong comment ay 40x1 cube. Very good. That is also our correct answer. So, dito yung mga nakakulay na same color, sila yung mga like terms. So, makakancel na itong 20x1 and negative 20x1. Tapos, ang natira na lang ay 60x1 cube and negative 20x1 cube, giving us the final answer of 40x1 cube. So, very good. So, tanda pa ang pag-solve ng partial property. So, same lang naman sila. Ang pinagkaiba lang is yung ating notation. So, kapag excess property, lalagyan nyo lang ng upper key, ng superscript na E. Ano? So, did you get this one? Nakuha nyo? Can we move to the next topic? Okay, thank you. So, punta na tayo sa ating sunod na topic, and this is the last part of our discussion for today, the heat effects on mixing processes. Okay? So, for this one, the heat of mixing as we defined by the previous equation, ito, so again, ang tawag natin sa mga delta ha, delta H, delta V, delta S, and delta G or the property changes due to mixing. Ano? So, kapag delta H ay the property changes of enthalpy due to mixing. Okay? So, this gives the enthalpy change when pure species are mixed at constant temperature and pressure to form 1 mole of a solution. So here in enthalpy change or heat effects of mixing, we have two ways or two approaches. So the first one is through the help of your enthalpy concentration diagram. So meron ito sa Paris Handbook, the enthalpy concentration diagrams. So these are diagrams. So ganito yung hitsura niya. So I think sa Paris Handbook maraming ganito, concentration diagram. So pwede nyo siyang tingnan. So when we say enthalpy concentration diagram, it is a plot of your enthalpy and the composition or the mass fraction. So kung makikita nyo sa ating x-axis, meron tayo ditong composition per weight. And then sa ating y-axis, nandito yung value ng kanyang enthalpy. Now, since this is a diagram, ang gagawin nyo lang, edi ipa-plot nyo lang. Ano, so let's say for example, excuse me, meron tayong given dito na 50 ang kanyang weight concentration. E di titingnan nyo lang yung tapat ng 50. Okay? So, ginagamit yung diagram. So, let's try to solve an example. So, we have here the given. Find the quantity of heat that must be removed to restore the initial temperature when pure water is mixed continuously with a 90% aqueous solution of a sulfuric acid to dilute it to 50%. So, una, meron daw kayong 90, 0.90. So, ito yon. Nandito siya sa pagitan ni 0.8 at ni 1. So, kaya nandito siya. Ano? And then, i-dilute nyo daw into 50%. So, nandito naman si 50%. So, ang tanong is, ano daw yung kailangang heat na matanggal? We are given here the equation. So, binigay rin na equation para mas accurate yung ating makukuhang sagot. Okay? Ayan. So, pakikopya ng equation kasi gagamitin natin yan pamaya. Ayan, kopyahin nyo muna yung equation. Okay, nakopya nyo na? Pa-heart react kung nakopya na. Okay. Thank you. So, I'm going to proceed with my presentation. So, simulan na natin ang gagawin. So, una, ilalabel natin ang points of your species. So, ganito na daw yung gagawin. So, ganito yung ginawa natin kanina. So, ilalabel yung points ng pure species, specify yung initial points, i-connect yung mga points, and then i-intersect ng final state. Tapos, may nakanote dito, the energy balance for this process assuming negligible kinetic and potential energy. Since wala namang nabanggit about kinetic and potential energy sa ating given, is just the difference between your final and initial enthalpies. So, tingnan natin yung graph. Ano? So ito yung ating una, i-label daw natin yung points ng pure species. So dito yung ating A, pure species siya, and then dito si B. Ano sa tapat noong given na 0.9. 'Di ba dito daw magsisimula sa 0.9. Ano, so ito yung ating initial point. Tapos dadalhin mo siya sa ating final point which is 0.5. So nandito naman yung iyong 0.5. So para malaman mo yung iyong final point, pagkokonikin mo yung ating tatlong points, yung ating initial point na 0, your species, etong ating given na 90% concentration at itong final state na dadalhin mo siya ng 0.5. So, igagraph mo siya patuwid, itong line na to, tuwid na line, and then hahayaan mo mag-intersect yung tatlong yon. So, hahanapin mo ngayon yung kanyang point of intersection, silang tatlo. Ano? So, saang part sila nag-intersect? Dito, sa bilog na ito. And then from this one, makukuha mo na yung properties. Okay? So, pakikuha ng ating properties. So, ang una, ang ating x. So, kung makikita nyo kapag tinapat, nandito siya somewhere dito sa negative, greater than negative 100. Tapos, yung ating x at 0.5, so nandito naman siya sa negative 303.2688. Okay? So, paano mo ito makukuha? Gamit yung equation. Ano? Isa-substitute mo yung ating value na 0.5 doon sa pinakopya kong equation kanina. Pati itong x. Pero kahit hindi nyo naman to kunin. Ano? So, nakuha nyo ba itong si negative 303? So, basically, isa-substitute nyo lang itong 0.5 doon sa equation. Kaya ko siya pinakopya sa inyo. Ano? Tapos ito negative 178, di si 0.9 naman ang inyong gagamitin. Okay? So meron tayong sabi natin for the energy change, meron tayong the difference between your final and initial enthalpies. So meron tayong negative 303.2688 minus negative 99.2991. And giving us our heat requirement na matatanggal na kapag sinimplify mo to, ang sagot ay negative 203.9667 kilojoule per kilogram. Okay, so yun yung amount ng heat na kailangan mong matanggal kung gusto mong ma-reduce from 0.9 to 0.5 ang property ng iyong solution. So, bali, gagraph nyo lang naman siya. So, yung equation, binigay lang siya for accurate result. Pero, pwedeng by graphing lang naman. Ano, i-estimate nyo lang yung values. Pero kapag ganito yung type ng problem, hindi naman ako strict sa exact decimal, lalo na kung by graphing iyan. So, meron tayong mga percent of error or acceptable answers. Kasi syempre, iba-iba naman tayo ng tingin. Kahit isang graph yung pinagtitingnan. So, let's continue with our last topic, the heat of solution. So, for this one, we are concerned with the solutions na. So, when solids or gases are dissolved in liquids, the heat effect is called the heat of solution. And based on the dissolution of 1 mole of solute. So, actually, this heat of solution ay para lang tayong nag-Heslo. So, kung familiar kayo sa Heslo, yun lang din ang gagawin natin for this one. Ano? So, let's have this example. Calculate the heat of formation of lithium chloride in 12 mole of water at 25 degrees Celsius. The heat of formation of lithium chloride is negative 408.610 joules, while the dissolution of 1 mole of this compound is 12 moles of H2O is negative 33.614 joules. Ano? So, sabi ko nga para lamang Heslo ang gagawin natin dito. So, paano iyon? So, puntahan natin muna yung heat of formation. So, meron daw tayong formation ni lithium chloride. So, ito yon. So, meron tayong lithium plus chlorine uh, will yield to lithium chloride. Ano? And ang kanyang heat of formation ay negative 408.610 joules. So, ito yung ating given. Next, dun tayo sa dissolution. Ibig sabihin, meron tayong lithium chloride madidissolve sa ating given na water so that we can produce the lithium chloride tapos yung kanyang hydrate na 12H2O. Ang kanyang given ay negative 33,614 joules. Now, by Heslow, we're going to simplify our equation. So ano ang makakancel sa ating equation? Dito sa ating reaction. Paano ba tayo nagka-cancel? 'Di ba magka-cancel tayo if yung isang component ay nag-appear sa right side tapos meron din siya sa left side. Ibig sabihin nasa opposite side sila. So sa components na nasa equation, ano yung ating maka-cancel? Alin kaya ay dyan yung nag-appear sa left side at sa right side? Tingin nyo. Alin? May nag-appear ba sa left side at right side? Ano kayang component iyon? Okay, very good. So that is lithium chloride. So meron dito sa right side na lithium chloride and left side. So pwede na natin siyang makancel. Ano? And then we can total the equation katulad ng ginagawa natin sa Hess law. So pagsasama-samahin lang natin yung mga natira. So meron tayong lithium plus 1/2 chlorine plus water will yield to this one, yung hydrate form ng lithium chloride. And then, since pinag-add lang natin yung equation, ganun din ang gagawin nyo sa ating mga enthalpy. So, pag-a-addin lang natin siya. So, meron tayong negative 408,610 joules plus negative 33,614 joules. Ano? And then, giving us the final answer, nakuha nyo ba ito? Tama ba ang ating final answer dito? Yung negative 442,224 joules?
Yes po.
Okay, thank you. So this is our final answer. Ano? So I guess this is the end of our discussion. So ito yung ating final answer. This is the end of our discussion for our today's topic. Sorry for the inconveniences, especially with regards to the internet connection. I hope I was able to deliver the lesson and you have learned something about the applications of solutions thermodynamics. So do you have any questions with regards to our discussion?